Hello everyone. In this video, we will learn how to solve for system of two equations, two unknowns using graphing. But before we get into this, we need to learn how to graph a linear equation first. The method that I'm going to show everyone to use to graph a linear equation is to use x and y intercepts and one test point. Like this method is so simple that if you just apply this method, you'll be able to sketch the graph very quickly instead of creating a table and pick different points and try to connect them. Okay, so this method is called x and y intercept and then one test point. So we will get to this one test point in a minute. But before we get to this, I would like to review the x and y intercept. What do they mean? Okay, x and y intercept are the coordinates where the graph intersect the x and y axes. Okay, so x-intercept is when you have y equal to 0 and you have a value for the coordinate x here. So x-intercept is a point, okay, or an order pair. So in this order pairs, you have the value for a, but y is always equal to 0. This a value, just a symbol representing there's a value for x. Okay, so for y-intercept, see this symbol b? Remember that equation that we are talking about, y equal to mx plus b? Y-intercept is when you let x equal to 0 and you will have a value for y here. Okay, so this order pairs will have x equal to 0. It is called the y-intercept. And for this particular order pair, x-intercept is when you have y coordinate equal to 0 and you have an actual value for x. Alright, so I would like to go over the steps how to graph a linear equation using x and y intercept and one test point. Okay, so like I could just repeat myself, but I explained with x and y intercept here. Determine the x-intercept by substituting y equal to 0 into the linear equation and solve for x. Okay, determine the y-intercept by substituting x equal to 0 into the linear equation and solve for y. After you have these 2 points or these 2 order pairs, you are going to connect these 2 points on the Cartesian plane and it will form a straight line for you. Okay. However, any 2 points can form a straight line. Whether we have a correct straight line is when we have to do a step called choosing a test point. Okay, so this test point is very important. You choose any value for x, any value for x except for 0, okay, which is easy to calculate. Then substitute this value into the linear equation to solve for y. Check to make sure this point stayed on the graph. Okay, so I can quickly draw this for everyone to explain what I mean by this. Okay, so let's say I have a graph like this, and on this I have the x and y axis. So I'm going to use a ruler to make sure that I am drawing this. Okay, yeah, okay. So I am using a ruler, but because I draw on my surface on the screen, so it may not be that good. Okay, so here I have y. So you label your x and y axes. So this is the positive y. This is the positive x. This is negative y, negative x. Just a quick review of the Cartesian plane. Okay, so if you found 2 points, okay, so let's say I found this point and this point. Like I said, you can connect these 2 points and then it will form a straight line. However, you need to know, do you have a correct straight line? Because it just happened to be this way, this point and this point. Okay, So let me erase this point. Then you connect this to, you still form a straight line, but whether or not you have a straight, the correct straight line, because it could be anything. So that's why you must pick a point on this graph, okay, and you substitute it into the linear equation to see if that point stay on the graph, because the 2 points that you have are the 2 points that satisfy the linear function that you have. So it can be any two, and any 2 points can form a straight line. So in order for you to know the correct straight line, you have to pick a point. Okay, any point that easy for you to calculate, substitute into the equation to make sure. So I will erase this because I will use this graph later to sketch the following two linear equation that I have here. All right, okay. So this step is very important. So let me go over this again. Determine the x-intercept, determine the y-intercept, then connect the 2 points. But the most important step is to make sure that we got it right. So you need to pick a point on the graph and test in both equations to see if it satisfies both equations. So right now, we are going to work at this example. And what I will do is I will combine the graphing lesson with finding the solutions of these two equations, two unknowns. Okay, so this is one equation that I have, one linear equation that I have with the x and y, and another linear equation that I also have also with the x and the y, and I need to solve for x and y. So in this case, we are solving for x and y. So we have to solve for this order pair. Okay, so this order pair will be true for the first linear equation. It also has to be true for the second linear equation. So this one is called the system of two equations and two unknown. And we need to use this in order to we need to have two equations in order to solve for two unknowns. And our two unknowns here is x and y. Okay, if you only have one equation and you have two unknowns, there's no way that you can solve for those two unknowns. You must have two equations, two unknowns to solve for this. After you solve for this, you will have an order pairs or a coordinate. You must present your solution as a coordinate, and x comes first, y comes second in this brackets. Okay, so the method that we need to use on here is we must use the graphing method. So in order for us to use the graphing method, we are going to sketch these two linear equations on the Cartesian planes. Okay, so how do we sketch these two on the Cartesian plane? We are going to use the step that I just indicate for everyone here. So we do one by one. Okay, then you see here, the point of intersection of the above two equations, two unknowns, x and y, will be the solution for these two equations. So what I'm going to do is I will create into a chart like this. Okay, so this is the first equation that I have. See, that is 2y, 2x minus y equal to 4. The second one I have it x minus 2y equal to minus 1. So let's double check that I have everything correct. Yeah, so this one right here, I rewrite it like this. This one right here, I rewrite it down like this. And the method I need to use is I need to find the x-intercept first. Okay, so x-intercept means I have to let y equal to 0, right? You let y equal to 0, and then you substitute this value into this equation to solve for x. So I have 2x minus 0 equal to 4. So where y is, I substitute 0 in. So then I have 2x equal to 4. Solve for x, divide both sides by 2. So I have x equal to 2. So the x-intercept I have in this case is an ordered pair where x equal to 2 and y is equal to 0. So this is an ordered pair, and I am going to circle that. Alright, okay. So that's one for this equation itself. So this is belong to this. Okay. So I'm going to do the same thing for my second equation. So also I let y equal to 0, right? So right here, what I have x minus 2 times 0 equal to minus 1. So you see that? Okay, so this will be x minus 0 equal to minus 1. So x is equal to minus 1. Therefore, the x-intercept for this equation itself will be equal to minus 1 and 0 as an ordered pair. So, okay, so we circle that. So that belongs to this equation right here. Okay, so the same thing I would do for the first equation is 2x minus y equal to 4, and I will find the y-intercept for that. So the y-intercept for this, that means I have to let x equal to 0. Okay, so I let x equal to 0. And what do I have? 2 times 0 minus y equal to 4. So where the x is, you substitute the value 0 into it. So 0 minus y equal to 4 and minus y equal to 4. So you have, here is a minus 1, an invisible minus 1. So you divide both sides by minus 1 to get rid of this. So therefore I have y equal to minus 4. So the second point I have for this is when x equal to 0, y is equal to minus 4 for this particular equation. Alright, okay. So I do the same thing for my next equation. My next equation is x minus 2y equal to minus 1. Since I let x equal to 0, I substitute 0 into here. Minus 2y equal to minus 1. Where x equal to, where I found the x, I put the 0 in. You see? Now I solve for y. So minus 2y equal to minus 1. What I need to do is I need to divide both sides by minus 2. So that will give y, and minus 1 divided by minus 2 will give me positive 0.5. So we write 0.5 so that we have a specific point on the graph. So in this case, you see, when x equal to 0, y is equal to 0.5 as an ordered pair, which is for the other graph. Okay, so right here, that's what I have, and this belongs to this, and this belongs to this. This belongs to that, and that belongs to that as well. Okay, now the test point, 1/3 point, is very important. So don't just like take these 2 points, sketch it, but you have to find a third point. So 1/3 point, you can pick any value for x. Okay, so let me lower this so everyone can see the graph that we are working with. So the easiest point you may want to pick is 1. You don't want to pick 0 because you already picked 0, 0, 0, 0 there. So let x equal to 1 to see what happened. Okay, so let x equal to 1. So I'm going to substitute x equal to 1 into the first equation. So it's 2 times 1 minus y equal to 4. So 2 minus y equal to 4. I'm going to solve for y in here, okay? So minus y equal to 4 minus 2. So minus y equal to 2. So y is equal to minus 2. So the point that I'm going to have for this particular graph is 1 and minus 2. Okay, so circle this and make sure that it belongs to this particular graph. So I do the same thing here for this equation. So this equation is x minus 2y. So I let x equal to 1. So 1 minus 2y equal to minus 1. So minus 2y equal to minus 1. Bring this 1 over to the other side. So it's a minus 1. So it's minus 2y equal to minus 2. So minus 2y divided by minus 2. Divide both sides by that to get rid of the negative 2 in front of the y. So y is equal to 1. So that means I will have the point 1, 1, and let me write it in blue. Okay, so I will have 1, 1, and this point is the third point belong to that particular graph. Alright, so let's move on to the next. We are going to organize this. Okay, so we are going to organize so we can graph. So I'm going to write everything that I supposed to have from the previous screen for you. So my equation is 2x minus y equal to, that's do we have, equal to 4, right? Okay. So the 3 points that I have for this particular one is 2 and 0. And then I have 0 and negative 4. Okay, and then I have 1 and negative 2. The other equation I have is x minus 2y equal to minus 1. So double check. Yes, x minus 2y equal to minus 1. And the point I have is negative 1 and 0. The next one I have is 0 and 0.5. And the last one I found is 1 and 1. Okay, so let's get this. Okay, so I'm going to zoom it in and use my ruler to sketch this for you. So I kind of know where I should get started. So I'm going to go here. Okay, so this is positive y and negative y. What I do is I will go this. Sometimes this software doesn't cooperate with me, but so far it's doing good. Okay, so this is my positive x. This is my negative x. Okay, so I'm going to identify these points on this graph. So I'm going to use red. Okay, so 2, 0. So where do you find 2, 0? So 2, 0 is, let's work with our scale first. So I am going to identify this as 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Negative 1, negative 2, negative 3. Negative 1, negative 2, negative 3, negative 4. Don't forget, this side is a negative. This is negative y-axis, positive y-axis, positive x-axis. And the scale I decide for this is 2 of this square will give me 1. Okay, so I will be consistent. So this is a 1. Okay, so this is a 2. So the point 2, when x equal to 2, y is equal to 0. So that point is right here. So this is 2, 0. Okay, and the next point is 0 and negative 4. So this is negative 1, negative 2, negative 3, negative 4. So this is my 0 and negative 4. Don't forget that, okay? So those are the x-intercept and the y-intercept of this equation. 2x minus y equal to 4. So let's say you never did that 1 and negative 2, but then you connect this 2, okay? So if we now plot this point, then the 3 point should stay on this graph, okay? So if you don't use this test point, if you get this 2 incorrect, you will have an incorrect graph. With the incorrect graph, you will have the wrong solution. Okay, so where is 1 and negative 2? When x equal to 1, y is equal to negative 2. So right here, 1, I go all the way down to meet the negative 2 of the y. So it's right here. Okay, so this point I will say it as 1, negative 2. Okay, x equal to 1, y equal to negative 2. So let's connect this. Are they on the same graph? Yes, they are. They are. They stay on the same graph. Okay, so I will get this in blue. Okay, very good. So I'm going to label this as 2x minus y minus, so let me write it down here. Okay, so let's reconnect this back, and I am going to label this as 2x minus y equal to 4. Okay, so I'm going to sketch the next point, and what I'm going to do is I will use purple as the next point, or maybe I can use black. Okay, so negative 1 and 0. Where's the negative 1 and 0? So right here, negative 1 and 0. So I'm going to make it as okay, so I don't think they let me use black. Okay, so I will put negative 1 and 0. So that is the point. And the next one is 0 and 0.5. So when x equal to 0, y is equal to 0.5, which is this point here. All right. Okay. So this point here is 0 and 0.5. Okay. So that is that point. And the last point is 1 and 1. So when x equal to 1, y equal to 1, so that is the 1. Okay, so I'm going to identify this one as 1, 1. So now let's connect the 3 black line, and I'm going to now put it in red. Okay, and 3, 2, yeah, okay. So we connect this. What we have is 3, Okay, so now I can tell you that the point of intersection is this point right here. If you connect, if you project it down to this, x equal to 3, y is equal to 2. So this is the point of intersection. Okay, so this point of intersection, 3, 2, is the solution for this graph, for this two linear equation. Okay, because when the two lines intersect, the point where they meet is the solution for x and y. Okay, so in this case, you are solving for two equations and two unknown. And then what you need to do is you need to sketch the graph using the concept of x and y intercept, x, y intercept, and one test point. So after you sketch the graph, what you do is you will see if you sketch it accurately, very accurately, okay, then you will find the point of intersection, and this point of intersection stays on both linear equation, so it is the solution for these two equations and two unknowns. Okay, so because what we did was we did it by hand, and then sometimes it's off a little tiny bit. But if I sketch it using software, so here's what I have. See here? So this is my 3, and this is my 2. Okay, 3 and 2 are the solution for this graph. Okay, so I am going to end this video here, but I will continue with the same lesson in the next video, where I will show you how to solve for this two equation, two unknown, and we have to test to see if we don't sketch the graph and we use a different method. Let's say we using algebra to solve for this, then is that easier so that we can have the exact same solution. Okay, so the solution is x equal to 3, y equal to 2 for the system of the two linear equation that we have. 2x minus y equal to 4, and x minus 2y equal to -1. Okay, so when we sketch, that's the point of intersection, but sometimes when we sketch, we don't have the exact point. And how are we going to solve for the system of two equations, two unknowns? And graphing is the least method, okay? It's the least usable method, because no one is going to use the graph in order to find the point of intersection unless you are using the software. Okay, you are using some sort of technology in order to sketch the graph. But if you want the exact point, what you need to do is you need to solve for this system of two equations, two unknown, using algebra. Okay, so that I will do on the next video. So I do have an exercise here for everyone to try, so you can go ahead and try this. All right, okay, thank you everyone.